This is going to be an information video about Modbus and Modbus TCP. Modbus is legacy, it's awfully old, awfully slow, but it's easy. And it's a real simple protocol, so it's easy to implement. You can even program this easily by yourself. So that's why it's popular. So it's kind of the least common thing that you can agree on with communication, use Modbus. But the protocol is awful, it's slow, it's yeah, whatever it is, something. Yeah, so we have a little look at it. Modbus and Modbus TCP. Modbus is done on RS-232 or 485 or so, the old ones, and TCP is, as it says, that's on Ethernet. And here is a reference guide that you can find. This is for free. It's old, 1996. Serial communication from 1979. So we are writing 2024. This has got to go. Open and free of charge, which is popular. You can just download, program it yourself, and so on. And it's what we call a master-slave query response. You say, send me some data, and what kind of data? Yes, return. You get the data return. So it's master-slave query. So you have a slave, ask it for data, and you get the data return. So here it is, query response protocol, and here what you can be on. Yeah. So it's application layer only. It's irrelevant what kind of other layers that you're using. I received a message and have execute request and knock. So you get say, I can do whatever you ask me to. This is basically what it says. So you get a data and you get the data return. Here is some Modbus RTU, which you kind of used as a binary protocol, the ASCII one, as it says, that's just ASCII format, and Modbus TCP on TCP. So these are the one that you use. This, I don't know if this has been used anymore, probably not. Yeah. I checked some is here included in the payload of the as with Modbus RTU. So it's two ways here. You can have on TCP, you can have the checksum, the standard checksum that you have in RTU, or you can omit that one and then use just the TCP checksum, which is 32-bit, and the checksum for Modbus RTU is a 16-bit CRC. Yeah. Yeah, and so on. Not interoperable. Yeah. Yeah, okay. It is what it is. And here is what it is. Here is the Modbus physical layer and then application layer. And if you get on TCP, it of course uses the TCP control stack. But then again, the Modbus is routable too if you're on TCP, so you can pass through routers too. And here is also an application protocol down here that you can have a look at. And here, Modbus mixed architecture that you have and how you can have it, drive and Modbus, and communication also laterally between PLC has been used a lot, and two devices and so on. And this, of course, this is really superb stuff that they have implemented here too. Yeah. Yeah. The medium access control principle is basically master slave. You ask a slave for data and he replies, but you can also have broadcast mode that you send to all slaves, and then you get the data returned. So you don't get anything back based on your broadcast and say, here is something for you to do, and so on. And all devices must accept a broadcast for writing functions. You must accept a broadcast for it. Well, also, yeah, for writing, yeah, but you can send a request to all slaves and you can get data back too. Yeah. Information exchange too. So what they do is they have addresses, we have a function call, we have the data, and an error check too. So that's the way it changes data. Protocol data unit, application data unit, so PDU is here, and additional address and so on. So what you have. Here is just one example. You can read this for yourself. We have a slave address here. We have a starting address. And this is just about register. What you have, they have input register, they have input bits, coils, register, holding register, which is outputs, and input register, and so on. So you ask just for physical addresses in the PLC, basically. There are no names. So this is what you ask for. And here is the query, and here is the response you will get with data and so on. And here is RLC, or CRC, then for the RTU that we are going to use. So there are two types. The message frame, what you can do is what we talked a little about. You can read holding register, read input register, 4 single coil, preset single register. These are the normal ones that you implement. And here is force multiple coils and preset multiple register. So it's 3, 4, 5, 6. That's what you usually use here too. Yeah. So these are the codes. So it is from Modicon. So this was just you communicated with the memory in the PLC. You asked for data or PLC memory. So this is old. Yeah. And what is variable here too? There's just 4 single coil. Force data how is there 16 bits, and here's what you get a response. Yes, I have done this. Force this single coil. The CRC is a CRC 16. Yeah, so if the test, we're talking about CRC test, the LRC, we're going to talk about. Cyclic return to check. It isn't that difficult because you use tables, so it's easy to implement too. And it's this document, it tells you how to implement this CRC check. Like you can even copy these tables into your program and use this as a lookup table. But this is the algorithm too. So I don't know what the Hamming distance is here or something, but for these short telegrams, it's sufficient. Yeah. Here's another one, write single register too. And here's the error code. What you see here's the function code. We return it with an 8, which is the most significant bit set. So you can just check that. Check the most significant bit. Then there's an error in response. So it can't do whatever you ask the slave to do. Yeah, what you can do about it, yeah, you can just report it. Okay, this didn't happen. And then is Modbus TCP, where you got the PDU, but you have a Modbus header additional. It says what it is, identifier, the length of the telegram, and unit identifier. So, and you get this returned to most of it is just copy, you just get returned. And there's no CS at the end of the telegram, CSS generated TCP, and the OC layer 2 protocol, which is not, there is an option to have Modbus RTU on TCP. Then you also have the cyclic redundancy check on the RTU telegram too. So then you have basically 2 CRC telegrams. I don't think there's a lot of people implementing Modbus RTU telegram, but when I made this protocol, there was an option using both of these two. Yeah, here's an example too. High and low 16 bits here, length of it, and unit identifier too. And here is the Modbus. This is just the standard Modbus stuff that is on the Modbus RTU itself. Yeah, architecture, what you can have too. You can get gateways too here from TCP and so on and down to serial Modbus. So there are some options that you have for topology too here. Again, that is most of this is collected out of this application protocol that you can download. So that was introduction to Modbus TCP, and hopefully Modbus, we are going to see the back of Modbus too. But that won't happen anytime soon because it's widespread. It's used everywhere, and it's a simple protocol, slow, but easy to implement. You can implement easily a software, write a PLC program to implement Modbus is easy. And usually for almost all PLC vendors, even Siemens, they have Modbus in firmware. So you don't have to write your own protocol. You get it as a library or just as in firmware. some way. So most can speak Modbus, and that's why it's so popular. It's simple, popular, but it's not really innovative and modern in any way.